Section 2.5 is on zeros of polynomial functions. Okay, the first fact is that a polynomial of degree n has exactly n zeros. When they say it has exactly n zeros, they're including duplicate zeros, so including multiplicity. This is including irrational zeros. Complex zeros, I mean, if you went all the way down and included every possible zero, there would be exactly n zeros for a polynomial of degree n. Okay, the rational zero test gives you an idea of what kind of zeros to expect if there are any rational zeros for the function. Okay, so the possible rational zeros are in the form p over q, where p is the factors of the constant term, and then q is the factors of the first term. And this probably looks familiar from last year. So in this case, for example, when we're going to factor over rationals, that means I'm going to factor it till I've gotten all the rationals out, but I'm not going to include imaginary numbers or anything like that. We will in the future, though. Okay. Last section, they gave you a zero to start with. In this section, you need to find the first zero. So I need to figure out which values will give me a zero. And instead of randomly guessing, I'm going to use the rational zero test. Okay, the rational zero test says, look at the last term, the constant term, and think of the factors of 15. Okay, so it could be positive or negative 1, 3, 5, or 15. Okay, and then I look at the factors of the first term. Okay, this is actually a 1, so what is it? It's just 1. Okay, so if I want to know the possible rational zeros, okay, I'm going to list them out on your work. You probably won't unless it specifically asks you to. Okay, that's going to be all of these numbers divided by all of these numbers. Because this is 1, if I divide by 1, it doesn't change any of the values. So the possible rational zeros are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Okay, if this polynomial has a rational zero, it's going to be one of the ones I put on my list. Okay, I need to find one that works first, and I can move forward from there. You can either substitute these values into the function to see which equals to 0, or you can use synthetic division, or you could use long division if you like long division. I'm going to do synthetic because that's going to be my second step anyways. I don't know which one's going to work. You just guess, try the easiest ones first and see if they work. Okay, I'll put the coefficients, 1, negative 7, 7, 15. Okay, I'm going to randomly guess. Let me try 1 because 1 seems easy. Bring down the 1. 1, negative 6, 1. That's not going to give me a remainder of 0. Once I can see it's not going to work, I'm going to go ahead and pick another number. Okay, and again, I'm just picking randomly. 1 didn't work, so let me try another one. I could try negative 1. Maybe I'll try positive 3. I don't know. Let's try 3. Bring down the 1. 1 times 3 is 3, negative 4, negative 12, negative 5, negative 15, 15 minus 15, 0. This one gave me a remainder of 0, so this is one of the zeros of the function. And this is not the only zero of the function, so this is just one. Okay, so the directions tell me to factor completely. Since the function is given to me as f of x equals, I'm going to use f of x equals. Okay, because my first zero was x equals 3, then it must be true that x minus 3 is a factor of the polynomial. Okay, after I did the long division, I was left with this. Okay, if I translate that back into a polynomial, that's x squared minus 4x minus 5. Okay, and then it tells me to factor over the rational, so if I can factor more, I'm going to keep going. So I still have the x minus 3. Well, 5 and 1. So x minus 5 and x plus 1. Okay, this is completely factored now. It's degree 3. I got it all the way to 3 factors. And based on the factors I see here, if I had tried 5 as my first guess, it would have worked. If I had tried negative 1, that would have also worked. Okay, this time I'm going to try one that has some fractions in it. Okay, I'm going to factor this completely. I want to find a rational zero first. So I'm going to go ahead and look at the last term, which is 3. So the factors of 3 could be plus or minus 1 or plus or minus 3. I'm going to look at the first term because there is a more interesting coefficient. So the factors of 10 are 1, 2, 5, and 10. And I don't know the signs. Okay, so the possible rational zeros are my blue numbers over my red numbers in every possible combination I can think of. Okay, and you can normally simplify these in your head, but I'm going to write them out because these are notes. Okay, so it could be, no, I'm not going to write it out. It's too much work. Okay, I could have 1 over 1. I could have 1 over 2, and I'm going to assume these are all plus or minus. I could have 1 over 5. I could have 1 over 10. Did I do the 1 over all of them? Yes. Okay, now I'm going to use this 3 and put the 3 over all the possible numbers. Okay, so I could have 3 over 1. 3 over 1 is just 3. I could have 3 over 2. I could have 3 over 5. I could have 3 over 10. And I could have a positive or negative on any of these possible zeros. Okay, I'm going to hope that one of these works because that's a lot of numbers to check. Okay, now you might want to check the integers first if you don't particularly like fractions. I'm going to check the fractions first because I want to do a problem with the fraction. That's why. Okay, let me list the coefficients. 10, 33, 8, negative 3. Okay, you're going to randomly pick which one you think is going to work first. Okay, I'm going to try, I want to use a fraction. I'm going to try an easy fraction. I'm going to try 1/2. See if it works. Okay, 1/2 of 10 is 5. 33 plus 5 is 38. 1/2 of 38 is 19. 8 plus 19 is 27. 1/2 of 27, this is not going well. I can already tell it's not going to work. So 1/2 didn't work. Okay, and if you start getting crazy fractions, it's not your winner. Okay, let me try negative 1/2 and see if that works. Okay, negative 1/2 of 10 is negative 5. 33 minus 5 is 28. Negative half of 28 is negative 14. Negative 6. Negative half times negative 6 is positive 3, so I got a 0 here. Okay, so negative half works as one of my zeros. Okay, it's not the only one that works, but it's one of the ones that works, so I'm just happy to have one. Okay, I'm going to rewrite this. Now, the tricky thing is synthetic division is not the smartest of divisions. Okay, so if you got x equals negative half as one of your answers, synthetic division thinks of that only as x plus 1/2. Okay, synthetic always has the format of x plus or minus. Okay, I'm going to bring down the remaining polynomial, and then we're going to fix this because we don't want to leave a fraction in our factored form. We want integer coefficients. Okay, this looks a little better. Okay, there's a fraction. I don't like the fraction, but because they did this weird format for the first factor, your remaining polynomial is actually going to carry the extra factor. So if I look at this polynomial, I could actually factor a 2 out of that polynomial. Okay, so I'm going to bring down this crazy factor with the half. Okay, I'm going to factor a 2 out of my remaining polynomial. Okay, if I factor out a 2, now this is 5x squared plus 14x minus 3. And I needed to factor it out anyways because I was trying to factor it completely. Okay, now the nice thing is now I can give this 2, distribute it back to this factor. Okay, so if I distribute that 2 to that factor, now I'm going to have 2x plus half of 2 is 1. Okay, now this looks normal. Okay, and then I'm going to look at this polynomial and see if I can factor it more using whichever method. Some of you guys do grouping, some of you guys use the diamond, the square, the x. Whichever way works for you is fine. Okay, once I factor it out, or you factor it out using your method, this is my final answer. It's completely factored over the rationals. It's completely factored in general. And just glancing at this, I can notice that negative 1/2 worked as a 0, but 1/5 would have also worked, and negative 3 would have worked as well. So if I had done negative 3, I wouldn't have had to do the fraction in the synthetic division at all. Okay, example 2 says find a polynomial function with real coefficients and zeros 5, negative 2, and 3i. Okay, it specifically says real coefficients. Because if you try to write out these zeros and you use the 3i, when you distribute this out, you're going to end up with an I in your coefficient, and they don't want an I in your coefficient. Okay, so we're going to use the fun fact about conjugates to get another answer for this. Okay, because if positive 3i is one of our solutions, the conjugate, the complex conjugate, negative 3i, is also one of our solutions. And that's important because when I use that extra answer, it's going to make sure that all my coefficients end up being real. Okay, so I'm going to write a polynomial function. This is a polynomial function. So you could say f of x equals, g of x equals, y equals, but it should be an equation because it is a function. I'm going to do f of x equals. Okay, the first zeros are 5 and negative 2, which means x minus 5 is a factor, x plus 2 is a factor. Okay, and then I have 3i and negative 3i are also zeros. So x minus 3i and x plus 3i must also be factors. This is not a unique polynomial function, so you could make this a more complicated equation if you would like, but I'm not because this is complicated enough as it is. Okay, when you write your polynomial function, they want you to put it in general form, so they want you to multiply it out. Okay, how you multiply it out, which ones you do first are up to you. I can see that doing my two blue factors together is going to be easier, and doing the two green ones together is going to be easier because I can do them in my head. Okay, so for the blue ones, x squared plus 2x minus 5x is minus 3x minus 10. Okay, then if I multiply the two green factors, I get x squared minus 9i squared. But I know that I squared is negative 1, so negative 9 times negative 1 turns this into x squared plus 9. Okay, I have to now multiply these two together. Okay, whichever method you normally use is fine. Okay, I'm just going to go for it. X to the 4th plus 9x squared minus 3x cubed minus 27x minus 10x squared minus 90. I should have 6 terms. 1, 2, 3, 4, 5, 6. Okay, I think I have that right. And you typically put them in standard form, so in descending degree. So x to the 4th is first. Let's see, for where do I have for cubed? I have negative 3x cubed. And for squared, I have 9x squared minus 10x squared, so negative x squared minus 27x minus 90. Okay, so this polynomial would give me the 4 answers I'm looking for. Okay, we're going to keep going. This is a long section. Okay, so for example 3, the directions tell you to factor it into linear factors. Okay, linear factors are going to be degree 1, so I want something like x minus something, x plus something as my final answer. This also means that if I get it all the way to linear factors, I might have irrational factors, I might have imaginary factors. I have to keep going as far as I can. Okay, so for A is x squared plus 10x plus 25. That's an easy one, pretty easy one, I think. So I get x plus 5 times x plus 5, or I can write x plus 5 squared. Okay, and these are two linear factors because they're in the form x plus or x minus something. Okay, I'm going to do the next one. The next one's degree 3. I should be able to get 3 linear factors. Okay, I'm going to take out the common factor of an x first. Okay, now I look at this. I see x squared plus 9. That doesn't really factor over the rationals. So I'm going to find the zeros in order to go back and find the factors. Okay, and once you're used to these, for this one, you'll probably be able to do it in your head. Okay, so say I set that equal to 0. Let's see, x squared plus 9 equals 0, and I solved it. X squared equals negative 9. What do? I square root both sides, and I would get x equals plus or minus 3i. Okay, so I'm going to use my zeros to go back and write my factors. Okay, so I'm going to keep the x on the outside. Since my answers were positive and negative 3i, then my factors must be x minus 3i and x plus 3i. Okay, I had to take it all the way to linear factors, so I have exactly 3 linear factors. You could multiply them back out to check that you are correct, but it should match up with the zeros if you solve the zeros correctly. Okay, we're going to keep going on these, and these are just different strategies depending on the problem. Okay, C, degree 4. So when I'm finished with this problem, I should have 4 factors, 4 linear factors. Okay, it looks like a difference of squares to me. Okay, so this looks like x squared minus 9 times x squared plus 9. Okay, now x squared minus 9, I can factor that further for sure. That's x minus 3x plus 3. Okay, now for x squared plus 9, that's not going to factor correctly because it's going to give me imaginary answers. If you can factor that in your head, because you can imagine what the 0 is going to be, that's fine. If you can't, then I set it equal to 0 and find the zeros. What am I going to get? Plus or minus 3i again. Okay, and then I can use the zeros to go back and write the factors that produce those zeros. Okay, and then these are 4 linear factors, which is correct. It was degree 4. I was expecting 4 linear factors. Okay, next one's also degree 4. Okay, I'm going to see what I can do with it, and then I'll work from there. Okay, let's see. I can see this factoring. I'm going to put x squared and x squared here to get x to the 4th. Okay, to get 3, that's going to be 3 times 1. For it to add up to negative 2, that's going to be a negative 3 and a positive 1. Okay, this is a good first step, but I need to keep going until I get 4 linear factors. Okay, when they're in this format, if you can find the zeros in your head and then use those to get the answers, I'm okay with that because I think when you get used to these, you will do these in your head. Okay, but I'm going to do them on here so you can see where I get them. Okay, x squared minus 3. I'm going to set it equal to 0 so I can find the zeros. X squared equals 3. And if I square root both sides, I get plus or minus root 3. Okay, which means my factors were x minus root 3 times x plus root 3. And that does look like it'll multiply to give me x squared minus 3. Okay, for x squared plus 1, same. If you can solve for the zeros in your head, that's fine. I'm going to show the work. Okay, if I square root both sides on this, I'm going to get positive negative I or positive negative 1i. Which means my other 2 factors are going to be x minus I times x plus I. Okay, and these are now linear factors. It told me to keep going till I was done over the linears. If they had told me rational factors, I would have stopped at the first step. Okay, we're going to do a couple more like this just to show you different ways it might look. Okay, E looks like I might have to do the rational zero theorem, but I always check to see if I can group it first, because if I can group it, it's a lot less worse than the rational zero theorem, even though the rational zero theorem works very well. Okay, if I group this, I get x squared. Oh, that should be a 2 there. That's a typo. X plus 3. Then if I take out on the next pair, minus 5. Okay, so the x plus 3 is the common factor. X squared minus 5 is my remaining factor. Okay, because I want to put this in linear factors, I'm going to keep going. So I'm going to bring down the x plus 3. Okay, if I set that equal to 0, I would add 5, and then I would square root it. And I would get plus or minus square root 5, which means my remaining factors are x minus square root 5 and x plus square root 5. Okay, this is fully factored into linear factors, which is why I went here. If it had told me to only factor over the rationals, I would have stopped at this step. Okay, but this is fully factored. Okay, one more. Okay, x squared plus 6x plus 13. Can I factor that? 13 times 1. That doesn't add up to 6 at all. Okay, so I'm definitely going to solve it first and then use my answer to figure out the factors for this one. Okay, I'm going to complete this square. You might want to use quadratic formula if you're a fan of that. This looks very well set up for complete the square. Okay, I'm going to move the 13 to the other side. Okay, half of 6 is 3. 3 squared is 9. X plus 3 squared is negative 4. X plus 3 equals positive negative 2i. I'm going to move the 3 over. So it's negative 3 plus or minus 2i. Okay, well I found the zeros, but the point was to write the factors. So now I'm going to write the factors. Okay, so to get negative 3 plus 2i as my answer, I had to have, to get minus 3, I had to have x plus 3. To get plus 2i, I needed a minus 2i. Okay, to get negative 3 minus 2i, to get negative 3 I needed x plus 3, to get minus 2i I needed plus 2i. Okay, and if I set these each equal to 0, I should get those two as my answers, but it wanted me to factor, so I factored it. Okay, for example 4, I'm going to find all the zeros. When it says all the zeros, it means rational, irrational, imaginary, real, whatever kind of zero you need to find. I'm going to find all the zeros, which means exactly 3. Okay, just glance at it and see if it'll work by grouping, because that's always the easiest. It doesn't look like it's going to work by grouping. So I'm going to have to use the rational zero theorem. It doesn't say I have to list the zeros, but I should be thinking this could be positive or negative 1, 2, 5, 10. The coefficient's just a 1, so I don't need to worry about that. Okay, I'm just guessing which one might work. Okay, actually, if I could do 1, I can plug it in my head. 1 minus 6 plus, no, 1 doesn't work, because when I plug it in my head, it doesn't work. Negative 10. Okay, now one of those factors should work, otherwise there's no real zeros to this at all. Okay, I know 1 doesn't work because I just plugged it in my head. I'm going to try 2. 2, negative 4, 5. Okay, good. 2 worked. So it wants me to find all the zeros. I found the remainder 0, so I already know x equals 2 is one of my zeros. Okay, I need to find the other 2 zeros. And it doesn't tell me I need to write it fully factored, so I don't need to. Okay, let me bring this down. That's what I'm left with. I need to find the other 2 zeros, so I'm going to set this equal to 0. Okay, does that factor? 5 times 1, 5 plus 1 is 6. It doesn't factor. So I'm going to complete the square. I'm going to move the 5 over to the other side. Plus 4, plus 4. Okay, and you do need to show your work on these. Okay, square root both sides. X minus 2 equals positive negative I, so I get x equals 2 plus or minus I. Okay, and then just make sure you read the question so you answer it. Okay, find all zeros. Okay, so make sure you list all 3 zeros, because I got x equals 2 plus or minus I. That's 2 of my answers, but I also have the original one I plugged in, the one that I plugged in way up here. That's my 3rd zero. Okay, so if it's degree 3, make sure in your final answer you list all 3 zeros, including the one you found way at the beginning. Okay, we have 2 more examples, and they're similar to ones we've done before. They're just with a little extra something on it to make sure you can deal with it. Okay, this fact, complex zeros come in conjugate pairs, helps you figure something out. If you know one of the zeros is complex, you can normally find the other one. This was also true of irrational zeros. If root 5 is a 0, then negative root 5 is also a 0. Okay, so for example 5, it says, find all zeros. They tell you that one of the zeros is 2 plus 3i, and based on the fact that these come in conjugate pairs, that means that 2 minus 3i is also a 0. Okay, and you are going to need to use that fact to figure out the 3rd zero. Okay, so because I can't do synthetic division with these weird complex answers, I'm going to create the factors that produce these zeros and then use long division. Okay, so if I wanted to get 2 plus 3i as my 0, then the factor that produced that must have been x minus 2 minus 3i. And then when I solve it, I get plus 2 plus 3i. Okay, for my second factor, I want to get 2 minus 3i, so I'm going to make x minus 2 plus 3i, because if I solved this equal to 0, I would add 2 and minus 3i. Okay, I want to multiply these out. You can do 3 by 3, or you can notice that this is a difference of squares. Whichever way is the most accurate for you is the way to go. Okay, so this is actually x minus 2 squared minus 3i squared. X squared minus 2x minus 4x plus 4. Okay, minus 9i squared, but remember I squared is negative 1. So this is x squared minus 4x plus 4 plus 9, which is x squared minus 4x plus 13. And if I wanted to double check, I could always solve the equation and see if it works. Okay, now that I have the polynomial that I know is going to be a 0, I'm going to use long division to get the remaining 0. Okay, let's set up my long division problem. That's a lot of red. Okay, x cubed plus x squared minus 7x plus 65. And I'm dividing by x squared minus 4x plus 13. And the one advantage I have is that I should get a remainder of 0 because the polynomial came from the zeros. Okay, so x squared, to get x cubed, I need an x. X cubed minus 4x squared plus 13x. Okay, remember you are subtracting here. You don't have to mark it, but you need to remember that that's what you're doing. Okay. Let's see, those cancel. 1x squared minus negative 4. 1 plus 4 is 5x squared. Negative 7 minus 13 is negative 20x plus 65. Okay, to get 5x squared, I'm going to have to multiply by 5. 5x squared minus 20x plus 65. Okay, keep in mind you're subtracting. Okay, cancels, 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 remainder 0. Okay. Now let me go back and read the question to make sure I'm answering the question. Okay, it says find all zeros. This is degree 3, I'm going to get 3 zeros. Okay, so for my zeros, I got x equals 2 plus 3i because it was given to me. I got 2 minus 3i because I knew they came in complex conjugate pairs. Okay, my last 0 comes from this. If x plus 5 is a factor, then negative 5 is a 0. So those are all 3 zeros, and I got 3 zeros because it was degree 3. Okay, the last example for this section, and this is just a variation on what we've already done. It says find a cubic function with zeros 5 and 2i such that f of negative 1 equals 60. Okay, since it says a cubic function, this is going to be degree 3. Okay, it tells me my zeros are 5 and 2i. If 2i is one of my zeros, then I can assume that negative 2i is also one of my zeros because those are complex conjugates. That also goes along with the fact that this is degree 3, and now I have 3 zeros. Okay, they are adding a restriction that f of negative 1 equals 60. This means you are not going to have you will have a unique polynomial. There are not multiple answers. There's only one answer. Okay, let's go ahead and set it up. Okay, f of x equals, okay, I'm going to add a constant in front because eventually I'm going to have to make this work with f of negative 1 equals 60. Okay, now for my zeros, I have x minus 5, I have x minus 2i, and I have x plus 2i. Okay, eventually I'm going to put this in standard form, so I'm going to go ahead and start multiplying it out now. I think I'm going to multiply the complex conjugates together because I can do that in my head. Because that's going to be x squared minus 4i squared, which is x squared plus 4. Okay, I'm going to keep going. F of x equals a, multiply these out because I'm going to have to do it eventually anyways. X cubed minus 5x squared. Okay, now if it just told me I had to have these zeros, that kind of polynomial will work. Because they gave me the extra restriction that f of negative 1 must equal to 60, I need to plug negative 1 somewhere into this equation to make this work. Okay, now I could plug the negative 1 in for x at this step, or this step, and I will get the same a value. I don't want to do this as imaginary numbers. I could do this one. That wouldn't be too bad. I'm going to use this one because it's just easier for me to multiply these values together. I can do it in my head a little easier. I'm going to put it, where am I going to put it? Down here on the side. Okay, and this is because f of negative 1 equals 60. Okay, so if I plug in at that step, I have 60 equals a times negative 1 minus 5, negative 1 squared plus 4. Okay, I just plugged negative 1 here, here, and if I do that, I should get a 60 over here. Okay, if I do that, this is a times negative 6. 1 plus 4 is 5. 60 equals negative 30a. So I'm going to get a is negative 2. Okay, and if I had plugged in on a different step, I would have also got that a is negative 2. Okay, now I need to throw that constant in there so that now my function will give me the correct value. Okay, and because they're going to want it in general form or standard form, I am going to distribute this out to get my final answer. Okay, this is my final polynomial. It has the 3 zeros they asked for, and if I plug negative 1 into this function, I should get 60.